Shall we get started, y'all? We got a lot of information to cover in only half an hour, so let's hop to it. How's everyone doing?
Good.
Is this the fourth breakout session of the conference?
Yep.
We're feeling inspired, probably also getting a little mentally tired. That's okay. I'm here to just exhaust that with the amazing information we're about to drop. My name is Andrew Knight. You may also know me as the Automation Panda. I am a software engineer in test. I build solutions to testing problems. Right now, I am the lead software engineer in test for a company called Precision Lender, which is owned by a company called Q2. We do banking stuff. Ooh, exciting, right? So hit me up on Twitter, follow my blog. I also lead development on an open source project called Boa Constrictor, which is a .NET implementation of the screenplay pattern. So if you want to do your Selenium WebDriver test a little bit better and you're using C#, let me know. I can help you out, hopefully. So today we are not going to talk about Selenium or Boa Constrictor. We're going to talk about test data. Test data is one of the toughest challenges in testing any software product. When I say test data, I'm referring to multiple things. It includes both the actual data inside the product under test, as well as the data values used in test cases. As testers, we shouldn't underestimate this work to handle data properly. I've seen teams basically give up on test automation efforts because they couldn't figure out how to handle the data. Good data is just as important as good tests and good automation. So in this talk, we're going to deep dive. We're going to look at the connection between product data and test case data. We're going to learn how to pick the right strategies for handling both, including how to avoid collisions. And so I'm hoping by the end of this talk, you'll be able to manage the test data nightmare for your own test projects. Let's learn. Let's say we have an application for a bank to provide loans. Gee willikers. The bank could configure this application for many different types of loans, such as home mortgages, car purchases, and student loans. All the information the bank needs to provide loans must be stored in data in the system. Each loan product is different. It comes with its own rate, maturity, and pay schedule. The bank must also store information about borrowers, funding curves, and profitability targets for loan opportunities. It's complicated. If you were to join my team at PL, you'd learn a whole lot more about all this. And so testing requires that all this data already be present in the system as a prerequisite. We could write a simple test case to exercise the basic application behavior. And I'm going to show this test case in Gherkin because it's basically a pseudocode language for writing tests. Create a new loan application. Given the Chrome browser is open and the page myloanapp.com is displayed, when the user creates a new loan application for a home mortgage, and the user enters all their personal information, and the user submits the application, then the page displays a success message with a reference number, and the loan application is sent to the bank. If you're cringing on some of these steps, it's okay. We'll get back to that later. Now, bear in mind, a real loan application would probably need several pages worth of information, but let's keep our example simple. This test essentially creates and submits a new home mortgage loan application for the user. There are many test data points in this short scenario. Most apparently is all the user's information in this table. We also have the type of loan, the record of the loan application that was sent to the bank, the URL, and the reference number. Whoops, forgot that one. There's the URL for the config info, and there's also the browser type, which is a test input. Test data is everywhere in this short scenario. It is inextricable from the test. Without specific data, this test would be meaningless. Unfortunately, though, the term test data is rather ambiguous. We've applied it to both the product data in the loan web app, as well as to the various pieces of test case data that make even the most basic test work. Product data refers to real data living in the software system. For the loan web app, product data includes all the bank's product configurations and lending information. Test case data refers to data used to define test cases. It may include values to enter into the product under test, inputs to control how testing is performed, or records to retrieve from the product. In the latter case, test data is essentially a reflection of product data. Its values refer to entities existing in the product data. The two types of test data are separate but connected. Distinguishing these two types of test data is important to avoid confusion. The dependency of test case data on product data can be brittle. For example, consider our test case step to create a new loan application for a home mortgage. This step works as long as the bank's web app is configured for home mortgages. However, the product data could change at any time, just like product code. What if the specifics of a home mortgage application change? What if the loan is no longer called home mortgage, but a personal residential loan? All those fancy bank words. That would make this test case break. Compounding breakages cause nightmares for test management. So, how should we manage test data? For feature testing, test data is just as important as test cases and test code. How do we handle both product data and test case data? Are there strategies we can use to avoid brittle dependencies? In this talk, we'll explore multiple ways to handle both product data and test case data. Unfortunately, there's no universal or perfect solution to the test data problem, but you can avoid nightmares by picking strategies that work well for your needs. Let's start with product data. As previously stated, product data is any live data in the product or system under test. In simplest terms, it's everything in the database. Examples could include user accounts, admin settings, product customizations, any records or files created by the user. And in our loan app, specifically, they'd be things like user accounts, loan products, completed applications, and any of that behind the scenes bank data. Data must be present in the product as a prerequisite for most testing. There are two primary ways to get that data into the system. On one hand, you can set the data up before running your tests. This would be called static data preparation. For example, the loan web app could be set up with a set of pre-registered users and a collection of loan types. Test cases, whether they are manual or automated, can presume that this static data is already in the system and simply reference it. Static data preparation is a good strategy for complicated data or for data that's slow to create dynamically. For example, user accounts usually need some sort of email verification. So it might be easier for automated tests to simply use a set of pre-registered users than trying to go through that whole cycle every single test. Tests will run faster if they can simply reference existing data instead of creating new data each time. However, static data must be maintained. Any changes to static data could impact tests. It can also become stale over time, like when data formats are changed or if the data has timestamps in it. On the other hand, you could try to set up your data during test execution. This would be dynamic data creation. In the example loan test, the loan application document is dynamically created. It does not reference any existing loan application. It creates a new one. Dynamically created records avoid the brittleness of hard references to static data. They can also be used exclusively by the current test case, protecting them from interruptions by other test cases. The main downside of dynamic creation is the execution time. It is slower because you got to do it. And also, dynamically created data is essentially disposable. So at some point, you're going to need to clean that up. Which strategy is best? Honestly, you're probably going to need both strategies. Data that is slow or considered immutable should probably use static data prep, while data that is quick and easy should use dynamic prep. So, in terms of dynamic data preparation, how do you do that? That's going to depend on your test case and on your product. So it's very, very specific to the context. But Static data prep does have a few common strategies that we can look at together. The simplest data prep strategy is manual configuration. Fun, right? Yeah. It's exactly what it sounds like. Testers log into the system and manually create whatever records they need. They could be setting up users, creating product configs, what have you. The nice thing is it's low tech. Anybody can do this. Downside, it's slow, doesn't really scale. Every time you have to make changes, somebody got to go in there and do it themselves. So there's a time tax. Also, for manually configured systems, over time, they tend to decay, right? Things fall out of sync, things fall out of relevance, they're no longer fresh, things can come into disrepair, and so maintenance becomes a hassle. So what do we see whenever we have a problem with manual things? We automate it, right? Wow. So you can also have, automated mechanisms for handling your configuration. Rather than manually setting it up, you can use automated tools to either generate data that you need or to scrub data from production and copy it over. You could make your own tools, you could use libraries, you could even use configuration management tools like Chef or Puppet for certain needs. If you're generating your own data, you can do it deterministically or randomly, whatever fits. The main benefit of this is that you can get this data anytime. Whether you generate it or you scrub it, you push a button and it goes. You also have the ability to get fresh data so that if your data is time sensitive, you can get more up-to-date data that's not expired. Downside of this, though, is that like with any kind of automation, it's no free lunch. You've got to get the tools, you've got to get the skills, you've got to put the development into it. So, what's another way to handle static data? If you want a shortcut, you could clone the database. Cloning databases is easier than ever with cloud management tools. You could have one database in a golden state or a perfect state and simply clone it before you run your test suite. And then after your test's done, you can just blast it away. What's nice about this is that it's pretty easy just to clone everything. It's usually like one command. And if you have automated tests or even manual testers that go rogue and kind of destroy some things, well, that was a cloned database. You can just eliminate it and start fresh next time. Unfortunately, though, some databases have a lot of data, but gigabytes of data. So it may not be practical to clone databases in your setup. Plus, with clones, you may need to scrub certain fields, or you may need to do some extra steps to hook things up properly. If all that's a bit of a hassle, you could always try to mock your endpoints. This will completely remove dependencies on databases and services. And you could put whatever data you want in your mocks, whether that's something you generate or something you scrub, and it's just a quick, easy endpoint to get at. Typically, you want to set up your mocks to have kind of consistent results. However, mocks aren't always the best. They can be difficult to set up and maintain. And if you're putting in mocked data, you may be blind to real-world variations, right? So you may not hit certain edge cases. You may not think about that. And just side comment, if you're using mocks, it also means you're not doing end-to-end testing with your coverage, for better or worse. You can discuss that later. Which strategy is best? It's really a matter of which ones meet your needs. And furthermore, how can you combine these strategies to get some combo effects? For example, you could use automated scripts to configure product data in a golden database and then make clones of that for testing. So it's not an either or, it's a yes and. How do you choose? Multiple factors to consider. How big is the data? Is this something that you can handle just fingers at a keyboard, or do you really need to level up with automation tools? How fresh does the data need to be, and how frequently does it need to be updated? If it needs to be fresh, if it needs to be current, if it's always undergoing changes, you're probably going to want to favor some sort of automated tooling. How difficult will it be to do some advanced tricks like mocking? Real talk here, is there any bureaucracy that would prevent you from doing a certain solution? Has your org bought into automation? Do you have a healthy culture that would be okay with trying new things? I mean, it happens. Bureaucracy can be really nasty, but it's a factor to consider. Do the folks on your team have the skills necessary? And also, how much is it going to cost? None of those solutions are going to be free. They take people's time, they take compute resources. So, that's product data. Everybody good so far? I know that was a lot of information. Ready for more information? Open wide, because here it comes. Test case data is inherently part of test cases, as we already said. Let's look at that first step. Given the Chrome browser is open. The Chrome browser is test data because it specifies the type of browser in which to load the app. This is what we call a test control input. It directs how tests will be run rather than specifying feature behavior. Theoretically, this test should be able to run on any browser type, but the step here just dictates Chrome. As a best practice, test control inputs should not be hard-coded into test automation code. Please don't do that. Instead, they should be passed into automation as inputs. That way, tests can easily be retargeted. And there are a few ways to do this. The simplest way would be to create a flat file with input values. I recommend using a format like JSON, which is shown here, or YAML, because they're easy to write, easy to read, and easy for programming languages to parse. For example, Python has a JSON module where you could read this thing into a dictionary in one line. Love Python. Flat files like this can also have line-by-line diffs. Test automation code can read these files before tests start, and they can inject the values as appropriate into the tests. Excuse me. For example, using this JSON file here, automation could read the browser type and construct Selenium WebDriver objects for Chrome for each test. And if they were Firefox, it would create Gecko drivers. The path for the input file would need to be hard-coded into the automation, but it could be as simple as a standard file name in the current directory. An alternative way to handle inputs would be using environment variables. Tests could set variables from a system shell or profile, and automation could read those variables by name. This can be useful for integrations with CI servers or Docker containers. But it can be a little more dangerous because anybody can come and twiddle these values. Again, automation could read these variables before tests run and inject them, just like with the inputs from flat files. So, let's remove that hard-coded step for browser type from the test scenario. That can be handled as an automation concern. Next, notice how this URL is hard-coded. This is also not a good practice. Typically, development teams host multiple instances of products under development, like a developer environment, or a test environment, or a staging environment. Hard-coding configuration like that limits where the test can run. Any information about a product's configuration is called configuration metadata. This includes things like URLs, usernames, passwords, possibly other descriptors. There are a few ways to handle config metadata. You can use flat files or environment variables, just like we did for test control inputs. However, I recommend using flat files, and I also recommend separating test control inputs from config metadata. Create an input to refer to the target configuration and store multiple configurations in that config metadata file. That way, testers can change just a few simple inputs to target any configuration, and they won't need to change multiple configuration fields regularly. This would be excuse me. If you want to be fancy, you could even create a web service or use something like Azure Key Vault for hosting config metadata that you can access as a service. This would be great if you need to keep secrets safe. However, depending on your needs, that might be overkill. Either way, this test step can be rewritten to refer more generically to the web app. Automation can select the target environment using the inputs and config metadata. The remaining pieces of test case data fall into a category called test case values. Lots of definitions today. These values pertain directly to the behavior exercised by the test, not to any configuration factor. Even in this classification, there are subtypes. The first kind of test case value is a literal value. In this example, the table of personal info contains literal values. Literal values are simple to use, and they provide specification by example. Literals should also be independent of any statically created product data. They should be values that can be safely originated by the test case. The literals in this table will be entered as input values into the web app. And theoretically, they could be any values. The second kind of test case value is an output reference. These are values that are retrieved from the product under test. Typically, they are the outputs generated by exercising a behavior. So in this example, we have the reference number and the loan application as our output references. We didn't specify in the test case what these are, but rather the system generated these. And so we can't hard code what we don't know, so we refer to them by some sort of description. So we know there's going to be a reference number on a page somewhere. We know that there's going to be a loan application document sent to the bank, so we have output references to describe them. Also, as a side note, this whole application submission is an example of dynamic data prep we talked about before. So, the third and final kind of test case value is the trickiest. We call it the input reference. First, it may not look any different from literals like we saw on the table. But the difference here is that home mortgage refers to something in the product configuration. Excuse me. It's not an arbitrary value. It's not something that the test case can invent. It is referring to something already in the system. It's an input reference. So we have to assume that there is a loan type already in the system called home mortgage. If that's not in the system, this test ain't going to work. How do we handle input references? The simplest way is just to use some sort of hard-coded reference like this. Usually some sort of name or some sort of token where we can say, oh, I want to get the home mortgage loan product type. But as with any kind of reference, that has a potential to become stale, right? What if the product name changes? Or what if we're running on a different environment where in this particular region of the bank, they don't call them home mortgages, they call them personal residential loans. Why? Because everyone has to be their own special thing, right? So how do we handle that case? In that case, we can use something called data discovery. Let's say the web app is already targeting, is already configured with multiple acceptable loan types. Instead of hard coding this name, we can use a description for the home or for the loan type, and then use automation to search for a matching record in the system so that we can make some sort of call, probably like a backend API call to say, hey, I want to get a loan type that is like a home mortgage. And regardless of what its actual name is, our discovery mechanism here will give us a record with matching criteria so that we can use that appropriately regardless of whatever special region of the bank we're in. Discovery enables tests to search existing product data for required records instead of hard coding the records. It can make tests more resilient to changes in product data. And it's also really great when testing multiple environments with ever so slightly different configs. But I will warn you, discovery is expensive because you're going to have to add a whole bunch of extra calls like this to your code. I don't recommend discovery mechanisms unless you absolutely need them. They can be overkill for small projects. In summary, test control inputs direct how tests will be run, not what behavior is covered. They should be supplied via flat files or environment variables. Configuration metadata describe product configurations for the target environment. They should be supplied via config files or service APIs. And test case values direct behavior covered by the test. They may be literals, output references, or input references. And input references may be hard-coded or discovered. At this point, you're probably thinking, wow, that's a ton of information. That's it. We're done, right? It's Q&A. Frightfully, nightmare's not quite over yet. One more small detail to address. Collisions. Collisions can happen whenever multiple actors operate on shared resources. For example, if you have multiple testers testing the same system, or when automated tests are running in parallel, they might have a chance to step on each other's toes. So we just need to take a few extra considerations to avoid collisions. First and foremost, isolate your test environments. If you can dynamically create a new test environment using containers or something for every single test launch, do it. Guarantees perfect isolation. If you're stuck using a shared environment, make sure you have controls into place. Make sure that while tests are running, you're not going to launch other tests against the same environment. Make sure testers aren't going to be stepping on each other's toes. Perhaps you need to run tests overnight so that people doing stuff on the day won't mess up your results. Secondly, treat any shared data as immutable, meaning constant or unchangeable. If you are in a situation where you're in a shared environment, you're going to be using the same config data, the same product data. So anything that can be shared between tests, while one test is operating on it, don't change it. Because if your data is treated as constant, then multiple tests could access that same data at the same time without having to worry about one making a change to it that could break another test. And finally, use dynamic data prep as much as possible. Tests can't collide on data they don't share. Try to keep your static data to a minimum. You will need some, but try to minimize that. Statically created data is more likely to become shared data. Shared data is more likely to cause collisions. So, boom, that's it. We have covered a lot of material about test data in this past half hour. Quick recap of what we learned. There's two primary types of test data: product data and test case data. Product data can be prepared statically or dynamically. Test case data either controls how tests run or reflects product data. And you should handle references and shared data carefully. Overall, choose the best strategies to help defeat your nightmares. Every product is different. Every team is different. I can't prescribe exactly what y'all would need for whatever you're testing. So what I recommend is take these as suggestions. See what makes sense for you. See what doesn't make sense for you. Try to combine things in cool ways. Slay your nightmares. So with that, I just want to say thank you all for coming to my talk. I'm tired. I gave the same talk back to back. So be sure to check out my blog, automationpanda.com. Follow me on Twitter at automationpanda. I love to keep in touch with people. My name is Andrew Knight. I love doing this. I'm passionate about testing. If you have any questions, now would be the time. But otherwise, enjoy the rest of this QA Summit. Oh, thank you.